In this video I'm going to take you through the Armed Services Vocational Aptitude Battery maths sections, and we're going to go through all of the sort of maths that you need to be aware of in order to make a good attempt at this test. I'm not going to show you how to answer every single possible question. A lot of it is figure it out for yourself. I'm going to present the mathematics that's required, so you'll be knowledgeable about the maths that you need. So you'll have the mathematical knowledge, you'll know the techniques to apply, but you will have to figure out the question for yourself, but you have the knowledge required to make an attempt at it. So the first thing I'm going to say is the first step when taking the test is RTFQ. R stands for read, T stands for the, F stands for something else, rhymes with duck, or rather ducking, and Q stands for question. So read the something question. This is extraordinarily important. The questions are almost always written with some horrible trick that will trip you up and make you answer a completely different question. You have to answer the question you're given. So read it and read it again. Most marks will be lost by not fully understanding exactly what you're asked and answering the question. Good example, it'll ask you to calculate the average omitting the lowest score. People will just read the question, rush in, calculate the average, and they'll include the lowest score and get it wrong. So read the question. Okay, now there's no calculator allowed, and this is a problem. So we need to know a few tricks to be able to do the algebra properly, or rather the arithmetic. First trick I'm going to show you is cancelling zeros. So if you have something like 100 divided by 1,000, you can work right to left and score out the zeros. So you can score this zero out, you can score this zero out, and you get this zero and this zero. So you reduce this to 1 over 10. Same thing here, if you've got 120 divided by 30, you can score off the last zero, score off the last zero, rewrite it without the zeros. 12 divided by 3, and that gives you 4. So that's an important maths trick, allowing you to cancel away the zeros. Second trick, probably the most important trick you've got, is basically making a guesstimate. Sometimes you'll get a question and you'll go, really, how do you do this? I can't. My math isn't good enough to do something so horrible. And most people really can't do 3.284 times 0.18 without a calculator. But you can get roughly the right answer. And when you look at the multiple choice, you can say, well, it's definitely not these ones, and this one's the closest. So you don't actually always have to do the exact calculation. Getting roughly the right answer is sufficient to get you the answer, because you can rule everything else out. So here, instead of going 0.18, you can say, well, that's roughly 0.2. I mean, it's very little difference, so just say it's 0.2. Now, well, when you know your equivalence between decimals and fractions, you can say 0.2 is the same as a fifth, because, well, if you think 1 divided by 5, you get 0.2. So split 1 into 5 pieces, you get 0.2. Perhaps even draw it out, and you'd see that as being sort of 0.2. That's 0.2, and like that's the whole. Sometimes doodles help. Perhaps that doodle's not wildly helpful. But it illustrates kind of the idea. Dividing 1 by 5 gives you 0.5. So really what you're doing is, instead of multiplying by this 0.18, which is kind of hideous, just divide by 5. And so the other way we can think about it is we look at answers A and B. It's definitely not these. That divided by 5 definitely doesn't give these. So we're left with this. So we're down to 50-50 already, having no idea how to actually do the calculation, because our mental math is just not that good. So we can say this one's roughly 0.6, this one's roughly 0.4. So we do 0.6 times 5 is 3, well that's close to that. 0.4 times 5 is 2, that's way off. So we're going to go with answer C. Alternatively, the more proper way of doing it would be to realise that 0.18 is equal to 0.2 minus 0.02. So that gives you that. So you would take this number and multiply it by this, then you would take this number and multiply it by this and subtract them. And that would give you the actual answer, and that's dividing by 50. It's more clumsy, this way is easier. So when you're attempting these questions, if you see something, you go, oh yuck, I can't do it, the maths is too hard, my arithmetic's just not that good. Well, don't panic, just take your time and go, can I get close to the answer? And then you can start ruling things out that are way off. And usually there is quite a difference between the answers. So getting close is sufficient to be completely confident that you've got the right answer. Some more tricks. Often you have to work with ratios. They can be used in all sorts of different ways, so you have to practice these yourself. But the trick that I would advise you to use is divide by the smallest. Very easy to remember, divide by the smallest. So if you have the ratio of 225 to 9, which one's the smallest? Well, 9 is obviously the smallest, so divide both sides by 9, and 9 divided by 9 is 1. So the smallest divided by itself will always give you 1, so you'll get a ratio to 1 every single time. That's why dividing by the smallest is a good rule. And then divide this by 9 and you get 9, so you get 9 to 1. So you'll always get a ratio to 1 when you divide by the smallest, and it will give you the smallest possible ratio, because you can't get any lower than to 1. Another trick, often you'll get questions where you're having to scale things. So for example, you'll be told that 15 apples cost $7. What's the price for 105? So you're going to have to scale up. Very simple, don't worry about this yet. Step 1, you come up with some equation. Step 2, you find 1 equals. And the third step is you scale it up. So you're finding an equation for you're saying basically 15 apples equals $7. 15 apples cost $7, 15 apples equals $7, and I've just called it A. You're allowed to do that, just A for apple, not wildly complicated. And we say 1 apple, well, if 15 apples are $7, 1 apple is $7 divided by 15. And now we need to scale it up. We want 105. Multiply both sides by 105. This is one of the most important rules in maths. If you do one thing to one side of the equation, do the same thing to the other. Fast, super duper important rule. Do something on one side, do it to the other. That gives us 105 apples equals $7 over 15 times 105. So you have multiplied 105 by both sides. And don't worry about the arithmetic, just trust me, it's correct. 105 apples is $49. So 3 steps. Right, take the equation out of the question, read the question, work out an equation from the question. Find 1 equals, so get 1 on the left hand side of the equation, and then scale it up. And that will work every time for scaling type questions. Right, now let's move on to rounding, often asked about. Going this way to the big numbers, most people understand, but when we start getting into decimals, people don't necessarily know as well. So the first point, the first 0 after the decimal point here, we call the tens. So this is like a tenth, 2 tenths, 3 tenths. Then we've got hundredths as the second one, then thousandths, and then 10,000ths. So you want to remember all these, and then after 10,000s it's 100,000s. Then after 100,000s it goes millionths, and then 10 millionths, 100 millionths, billionths, 10 billionths, 100 billionths, and so on. But you don't really need to go that far. So let's move on and do an example of rounding. And apologies about the little jump. So we're doing rounding examples now. Right, so let's say we want to round so examples. So we're going to round 9 to the nearest 10. So really what we're thinking about is we've got 0 here, we've got 10 here. Where does 9 fit along there? A 9 somewhere up here. So 9 is closer to 10 than it is to 0. So then we would say the answer there is 10. So we wanted to do another one. Round 57 to the nearest 100. So let's think about it. We've got 0 here and we've got 100 here. So is 57 closer to 100 or closer to 0? Obviously 57 is closer to 100. So we would say that that answer is 100. something more difficult, say we wanted to round 9,842 to nearest, and we'll do part A, we're going to do it nearest 1,000, and part B we're going to do it nearest 100. So A, so is this closer to 9,000 or closer to 10,000? Well, 842 is telling you it's closest to 10,000. And if we look at what hundredth it's closest to, is 42 closer to 100 or 0? But it's closer to 0, so we're going to keep this at 800. So this is going to be 9,800. And for our last example, we're going to round, it's running out of space, we'll say 1.862, and I'll just put a comma and we'll just say hundredths. So which hundredth is it closest to? So this is the thousandths, so we're going to look at, and this is the hundredths here. So is this going to be rounded up or rounded down? Well, 2 is closer to 0 than it is to 1, so this is going to stay as 6. So the answer is going to be 1.86. So that's our rounding. So let's move on and look at something completely different. Let's look at percentages. So on percentages, first thing we have to be able to do, of course, is calculate percentages. If you can't do that, well, you're kind of in trouble. So let's say we had 10 men and 90 women. So what percentage is women? Is women rather. So the percentage in this case is woman divided by the total, so add everyone up and you times it by 100. So on the top you put what you want, and on the bottom you basically add it up, add everything up. So that's exactly what we're going to do here. So you say there's 90 women, so what we want the percentage of women, and the total is going to be 90 plus 10. So we're going to get 90 divided by 100, so we times that by 100, times 100, so that's 0.9 times 100, so that is 90%. And that's the basic idea of how you calculate a percentage. Often the questions are a little bit more difficult than that. They don't just want you to do something really, really easy with percentages. They perhaps want you to do calculations involving multiple percentages. So, for example, we've got an investment. You can see the sheet after this, so let's hide that because it's kind of distracting. That looks a bit better. Just hide that away. So investment of $1,000, and this loses 15% per year for, we'll say, 3 years. Right? The stupid way people think to do this is they go, oh, 15% one year, 15% next year. So we'll add these up. We'll say 15% plus 15% plus 15. That equals 45%. So we take 45% of that. That is completely wrong. Don't ever do that. It's total nonsense. Percentages don't work that way. This is the correct way to do that. We notice that 15% is the same as multiplying by 0.15. So we're going to start with 100% and we're going to lose 15% of it. Now, let's say lose and put 15 here, this will make more sense. Lose 15%. So start with 100%, we're going to lose 15%. So subtract those numbers, what are we left with? 85%. 85% is 0.85 in decimals. We're going to use this property to do the calculation. So we're going to break it down into years. Perhaps come over here. Let's do this in this little box here. So I'm going to say year 1. In year 1, we've got $1,000 and we lose 15%. Times that by 0.15 and we get $850. Year 2, well, we're going to take this 850 and that's going to be what's left. So do 850 times and we lose another 15%. And that leaves us with $722.5. The arithmetic here is a bit nastier than what you would be used to in an actual test. And year 3, we're going to have this coming down here. So 722.5 and we're going to lose 15% of that again. And so the final answer after 3 years is 614 and well, that would round to 13. And that's the final answer. So that's how you do some stuff with percentages. Now we're going to move on and look at how we work with fractions. So on to fractions. Vital thing you need to know about fractions is working with common denominators. It's absolutely essential that you have on the bottom of the fraction the same thing. So you can't just add a half and a quarter just willy-nilly. You have to make sure that on the bottom of the fraction you get the same number. And there is a technique to do it. You take this number, multiply top and bottom, you take this number, multiply top and bottom. We'll see how that's done in a minute. And if you draw it out, it becomes incredibly clear that you have to have the same number on the top, the bottom when you add. You have to do it in a proper way. So a half plus a quarter is 3/4. That's the right answer. And so you draw out a half's this, a quarter looks like this, and well, this is the half plus a quarter. This looks like 3/4. Whereas if you just go, oh, I will just do it simply, we'll go 1 plus 1 is 2, 2 plus 4 is 6. That just gives you complete garbage. You think a half plus a quarter is this 2/6, which looks like this. Well, that plus that does not give that. That's just completely and utterly ridiculous. So let's actually do some examples with fractions. There's a couple of things you have to be able to do when you're using fractions. I'll put that in so you can't see what's coming next. I don't want spoilers. So you need to be able to add and subtract. It's an important skill. So say you're doing a quarter plus a quarter. Well, it's the same thing that we've got here. So you get 1 plus 1 is 2, and that's over 4. And you can simplify these down. You see, you can divide the top and the bottom by 2. So 2 divided by 2 is 1. 4 divided by 2 is 2. That gives you a half. Say we had the quarter plus the half. So we do this rule I told you about, times 4 times 4. That's the 4, like that. And then times 2 and times 2. This 2 is going like that. So 1 times 2 is, guess what? 2. 4 times 2 is 8, plus 1 times 4 is 4. 2 times 4 is 8. 2 plus, so we're going to add these two fractions. 2 plus 4 is 6, and then we're going to get 8 on the bottom. Don't add these. Don't just get out of the way of going 8 plus 8. No, just add the tops. Get the bottoms the same and add the 2 on the top. And well, we can simplify this. We can say, well, what could we do with this? Well, we can divide by 2 again. If you keep dividing by 2, you usually get the right answer. But you want to find the highest number. But in this case, we're just going to do 2 because it works. So that gives you 3 over 4. 6 divided by 2 is 3. 8 divided by 2 is 4, and that gives you your final answer. Multiplication. So multiply. So say you've got a quarter times a half. Well, you do top times top is 1, bottom times bottom is 4 times 2 is 8. And this makes sense if you draw it out. Basically what you're saying is you've got the whole, and then you've got a quarter. So this is the quarter here, and then you're dividing that in half. And that's going to be 1/8 in there. Sometimes doodles help. So dividing, another important skill. Divide. This is in English, but I should be able to spell. So say you're doing this quarter divided by 1/2. The rule is you take the second fraction and flip. So you flip it upside down. So you get, and you change this. This becomes a times when you flip. So you're getting a quarter times 2 over 1. Flip it. Just copying. So taking this, flipped it upside down, so we get 2 divided by 1. Top times top, just the same rule as here. We're going to get 2, 4 times 1, we're going to get 4, and then we can simplify this. Guess what? Divide by 2, so we're going to get 1/2. Last thing, if I just squeeze it in across here, that you're going to have to be able to do is you might get something that looks horrible, like 6.5. Ooh, that looks different. Plus, we're going to do, say, 2 1/4. So the trick here is we can split this up and do 6 plus 2 plus 1/2 plus 1/4. So this gives you the right answer. So 6 plus 2 is 8, and then we're going to add to that, well, we can just steal the answer from here, plus 3 over 4. So we're going to get 8 3/4. And this is just the same as 8.75. The alternative way to do this, if you prefer working in decimals, is to say that this is just the same as 6.5, 6.5, 6.5, plus 2 1/4 is 2.25, and if you add that, you get 8.75. That's the alternative. Perhaps simpler, perhaps not. Right, next thing we're going to look at is powers. Powers are very important and thankfully not hugely difficult. Right, so see if you can spot the pattern here. So 2 squared is 2 times 2, 2 cubed is 2 times 2 times 2, 2 to the power 4 is 2 times 2 times 2 times 2, and 2 to the power of 5 is 1, 2, 3, 4, 5, there's 5 of them. There's 4, 3, 2. So this number here tells you how many 2's. And when it's power 2, we say that's squared, and power 3 is cubed, and then we just go 4th, 5th, 6th power typically. And the other thing you need to know is that 2 to the power 0 is 1, and 2 to the power 1 is 2. So 2 to the power 0 has its own rule. Any number to the power 0 is 1, and any number to the power of 1 is always going to be itself. So, worth bearing all this in mind, these are very important rules. Square roots, other important feature of mathematics. And essentially, all you're doing is you're doing a kind of power backwards. So in the case of a square root, it's all about squares, so power 2. So 2 squared is 4, and the square root of 4 gets you back to the 2. 3 squared is 9, and the square root of 9 gets you back to the 3. 4 squared, 16, root 16 gets you 4, and 5 squared gives you 25, and the square root of 25 gets you back to 5. And if we look at just a kind of definition, and we'll use root 4 as an example, square root 4 is equal to, you can kind of think of as the answer to the question, 4 is what number squared. What number squared gives you 4, and in this case it's 2. There is an equivalence with powers, I might as well just mention that. The square root is the same as the power of 1/2. May not be of any use, but if you take the square root of a doodle, it's the same as that thing to the power of 1/2. Maybe useful, maybe not. Something that is definitely and absolutely always going to be useful is BODMAS. And this is the order that you do things in. So we've got BODMAS written out here. B for brackets, order, so squared, square roots, cubes, division, multiplication, addition and subtraction. So you do it in this order. So start here, finish down here. So always do the calculations in this order. If you do it in a different order, you get the wrong answer. This is extremely important. You must always do calculations starting with the brackets, then do this, then this, then this. Always go this way, otherwise you'll get it wrong. And so let's do some examples seeing this in practice. So examples. So say we've got 2 plus 5 times 3. 2 plus 5 times 3. So let's pull up our thing there. We've got a multiplication and an addition. It's upside down. So multiplication, and we've got an addition here. So this is going to be done first. We do the multiplication first. So this comes first. So we're going to get this equals 2 plus 5 times 3. Guess what? It's 15. And that's going to give you 17 as your answer. Let's try this another way. Instead of that, what if we had 2 plus 5 times 3? Notice these are similar, but we've put the brackets around these bits instead. So look at our rule. What comes first? We've got an addition, a multiplication in brackets. So, well, we have to do the thing in the brackets first, and then the multiplication is going to be second. So it goes in this order. Brackets, so we've got 2 plus 5 in the brackets, so that's going to be 7. And we're timesing that by 3, and that's going to give us 21. So notice, these look the same, but we've just done this kind of calculation, but the brackets have made us do it in a different order, and the order changes the answer. It's very important that we are aware of that order. Let's zoom across here and do a really nasty example. So say we had something like 2 plus 7 squared divided by 9 plus brackets 5 times 4 over 2. So let's think, well, here, just put this stuff, we're going to call this B for brackets. B for brackets. Brackets always done first, so let's do the brackets. So we're going to get 9 squared. 2 plus 7 is 9, we put the squared on. Then we get 9 plus 5 times 4 is 20 over 2. So what's next in our list? So we've done the brackets, we know that's first by now. Next, order, so we're going to have to do the squareds. So 9 squared is 81 divided by 9 plus, and we'll just keep this the same, 20 divided by 2. Right, what's next? Well, BODMAS, B-O-D, so divide. 81 divided by 9 is 9. You may notice a kind of property at work here, the concept of a square root. 9 squared. You see, you could also just like score that and score that, but we'll not bother with that now. And then that is of course 10, so the answer is 19, the addition coming last, obviously. Alright, let's move on. What we've got next, evaluating formulas. This is really important, so perhaps in the exam you'll get some formula. You might be told that z equals x plus 3 and that x is 2. This isn't difficult. The x, if you have some x, this just stands for a number. This could be anything. And well, you're told it's 2, so just stick the 2 in. So z equals 2, replace the x with a 2, plus 3, which is 5. Not terribly difficult. Somewhat more difficult is solving for x. This is an extremely important skill in maths. So let's just zoom across onto another bit of paper. And well, we want to hide what's underneath that. And my stuff's encroaching. Alright, so get rid of this. Yeah, I'm getting through quite a bit of paper here. So, solving for x. Flip this forward again. So, we've got an equation, let's say, just like the one before, x plus 3. And instead of being given x, we're going to be given what z is. So we're going to find x if z equals 5. And just as before, that can go in just like that. So the equation now becomes 5 equals x plus 3. Now remember the rule we talked about earlier, if you do one thing to one side, you have to do it to the other side. So we're going to subtract 3 from this side and subtract 3 from this side. So you get 5 minus 3, that's going to be 2, and we're going to get 3 minus 3, which is going to just leave us with the x. So that's basically our answer. But this isn't a nice way to write it, and it's perfectly okay to switch these round. It doesn't change anything. So x equals 2 is our answer. Now let's look at another example, just draw a nice line there. So z equals 5x plus 1, and we're going to say z equals 11, find x. So 11 is going to go in there. So you're going to get 11 equals 5x plus 1. So we're going to minus 1, minus 1. So 10 is equal to 5x. Alright, so we don't want 5 times x, we just want x. So divide both sides by 5. So you're going to get 10 divided by 5 is 10 divided by 5, that shouldn't be difficult, that's of course 2 equals x, so x equals 2. Just a coincidence that they're the same answer, it's not terribly important. Now let's look at inequalities. This follows on logically. So we talk about greater than, so you could say that 5 is greater than 1, this is a symbol for greater than. 5 is bigger than 1, 5 is greater than 1. Less than, the arrow goes in the opposite direction. So 1 is of course less than 5, it's not a shock to anyone. And then you've got the concept of greater than or equal to. And then you've got less than or equal to. So x could be greater than or equal to 5, so that means x could be 5, 6, 7, 8, 9. So it could be any number greater than 5 or 5 itself, but it can't be 4, 3, 2, 1. It can't be anything that's less. And occasionally you may be asked to solve an inequality. So you might get something like x minus 2 is greater than 6, so find x. So x is greater than something, or x is less than something. Or you might get something more difficult like 2x plus 6 is less than 3x. So what can you say about x? What could x be in what range? And basically this is fundamentally the same as solving for x, but, and the important rule is, if you're multiplying it by a negative, you switch. So when you multiply through by a negative number, greater than becomes less than, and less than becomes greater than. So these things switch around. And we're going to work on a example. So we'll slide that in there so you can't see what comes next again. Don't want spoilers. Perhaps this isn't wildly exciting to you, but it's necessary. You want to pass this exam, you want to get in, and you want to do well. So we'll keep going. So example, x plus 5 is less than 8. So rearrange this, so minus 5, just as before. So we get that x is, you see the 5 goes, 8 minus 5 is going to leave us with 3. So x is less than 3. So let's call it example 1. We're going to do a couple. Example 2, and they'll get progressively more difficult. 12 is less than x plus 4. So minus 4 minus 4. So 12 minus 4 is 8. Less than minus 4, so x. And this is technically correct as an answer, but perhaps it doesn't match up with a multiple choice. And the reason will be is because it's probably written the other way around. So 8 is less than x. If you think about it, think for a minute, this should be obvious to you. This could be written alternatively as x is greater than 8. So if 8 is less than x, that means that x must be more than 8. Just switching it around, that's perfectly acceptable. And the last example is going to be the hardest, but not terribly difficult. X plus 1 is less than minus 3, and we're going to use a rule here. So we need to subtract 1 from both sides, so we're going to get x is less than minus 4. And, this is minus x. So minus x, you have added the minus. Minus x plus 1 is less than minus 3, subtracted the 1's, and we're left with the minus x is less than minus 4. So we're going to have to multiply this by minus 1. And we're going to multiply this by minus 1. Remember our rule, if we multiply by minus 1, we have to change this. So this is going to have to change, that's going to go this way, because we've multiplied by a minus. So we're going to get x minus 1 times x, that becomes positive, and minus 4 times minus 1, that becomes positive. When you multiply something, negative times negative, negative times negative equals positive. Positive times negative is negative. This is an important rule, and unsurprisingly positive times positive is of course positive. So just finish that there. So minus times minus is positive. It's like not in English. I will not do that. That is, I will do that. That's the way people tend to remember that. And so lastly, let's flick through some other stuff you should know. This is kind of more the mathematical knowledge section. And we'll just fly through a couple of final points and then we're finished. So we have the concept of the mean or the average. There's various types of averages, but the mean is the most used one. And the mean is fantastically simple, you'll be glad to hear. Basically the mean or the average is equal to, and I just write it this way, it's not particularly rigorously mathematical, but it works. You go add them up and then divide by count them. So here's some data, 1, 5, 7, 9, 3. So add them up, 1 plus 5 plus 7 plus 9, just add them all up and then count them, 1, 2, 3, 4, 5, and put that there. So count them on the bottom, add them up on the top. 25 divided by 5, that added up gives 25, and 25 over 5 is 5. Not difficult. Next thing, factorials. I have no idea why you have to know about these, but it's in the list. Thankfully they're simple, but generally they're not used until quite advanced math, so I have no idea why these are at all important to you, but it's in the list, so you must know it. There's a clear pattern here. You maybe have spotted it already while I'm ranting. So 2 factorial is 2 times 1, 3 factorial is 3 times 2 times 1, 4 factorial is 4 times 3 times 2 times 1, 5 factorial is 5 times 4 times 3 times 2 times 1. Pattern, you're taking the number and multiplying it by every number that comes before it, but remember that 0 factorial is 1 and 1 factorial is 1. These are the special cases. And that's really all there is to factorials. They are very, very useful in advanced maths, but in everyday kind of maths, the level that we've been going through, they're not really relevant. Circles, more relevant. So 3 things you have to know about a circle is if you take this is the center of my badly drawn circle, a line that goes from one edge to the other and passes through the middle is called a diameter. One that goes from the middle to any point on the outside is called a radius. And the distance right round, like here, a bit like perimeter, but the distance round here is called the circumference. We're going to call the circumference C, the diameter D, and the radius is going to be called R. And there's a couple of relations. You get that the diameter is 2 times the radius. This is not surprising. From one side to the other is double from the middle to the edge. So this, you imagine if we drew another one kind of along there, that's double when you add them together. This plus this is the same as this, or 2 times this is this. Pi is probably a number you've heard of. People like to put it on t-shirts. You also have the factorial on a t-shirt. They have factorial exclamation mark, and that's a joke people like on a t-shirt. The circumference is related by pi. If you take pi and you times it by the diameter, you get the circumference. And the area of a circle is 2 pi times r squared. Worth just memorizing these, as well as the definitions that I've put in the description below. Angles, worth just knowing a couple of simple definitions. A right angle is 90 degrees and it looks like this. An acute angle is not quite 90 degrees, it's some angle less than 90 degrees. An obtuse angle is greater than 90 degrees. If 90 was up the line up there, it's gone past that. So we call that an obtuse angle. And lastly, we'll just touch on the idea of area and volume. Sometimes you have to do problem solving type questions, which can be quite tricky, but if you don't know what area or volume is, you're never going to get it. Nice and simple. If you've got something here and you want the area in here, you do length times its breadth, just multiply those two numbers. And if you want the volume, so all of this in 3 dimensions, you're going to have to do this here times this here times this here, length times distance times length times depth times height, and that gives you the volume. So there, I think we've run through the majority of the stuff that's likely to come up in your test. This isn't sufficient. Simply watching this video will not get you a good mark, but it will ensure that you've experienced the sort of mathematics that's involved, and you'll be able to confidently attack some of the questions. With extensive practice applying these concepts, the exam is manageable, but you really have to do endless questions. Practice is the most effective way of learning this. Simply watching this video is just giving you the kind of tools to go on and do your practicing. But I really hope that this has been helpful to you, and it's free from your perspective, so you don't have to waste any of your money. And finally, thank you for watching.